ideal gas equation we have already discussed is PV equal to nRT. Today we are going to discuss the difference between the ideal gas equation and the real gas equation. Now the main difference between ideal gas equation and the real gas equation is because of the 2 points. One is in the pressure and the second is in the volume. Applying two correction factor on the ideal gas equation, one in the pressure. Because of the intermolecular force of attraction, there is a difference in the pressure of the ideal gas and real gas, and the volume occupied by gas particle is not negligible. Therefore, there is a correction factor to be applied in the case of volume. Discussing the real gas equation or the van der Waals gas equation. We are going to apply the two correction factor on the ideal gas equation so that it becomes applicable for the real gases. The van der Waals gas equation is P plus A n square by V square into V minus NB equal to nRT. Here A n square by V square, this is known as the pressure correction factor, and this NB is known as the volume correction factor. This A and B are known as van der Waals gas constants. A tells us about the intermolecular force of attraction present in the gas particles, whereas van der Waals gas constant B tells us the volume occupied by the gas particles. If the van der Waals gas constant A value is greater for a gas particles, it means the intermolecular force of attraction between gas particle is more. And similarly, if the value of B is more for the gas particle, it means volume occupied by the gas particle would be more. There is another relation for the van der Waals gas constant B also. It is B is the volume occupied by the 1 mole of gas particle. So its value can also be expressed in another terms, that is volume occupied by the one particle is 4 by 3 pi r cube while assuming it to be spherical in shape, and for 1 mole of gas particle multiplied by the Avogadro number, experimentally this value comes out to be 4 times of this. So van der Waals gas constant B is equal to 4 into 4 by 3 pi r cube into Na, where R is the size of gas particle and Na is the Avogadro's number, and its value is 6.023 into 10 raised to power 23. So this is the another relation between the van der Waals gas constant B and the size of particle R. To find out the van der Waals gas constant A, we have given the 2 moles of a gas in a 4 liter of flask which are exerting a 11 atm pressure at temperature of 300 Kelvin. The value of B is 0.5 liter per mole. For this we need to use the van der Waals gas real equation. So the van der Waals real gas equation is the van der Waals real gas equation. By placing the value of the pressure, mole, volume and van der Waals gas constant B, temperature and the R, we can find out the value of A. Now we have placed the value of P to be 11 atmosphere, number of moles 2 moles and volume of the flask to be 4 liter, van der Waals gas constant to be 0.5, and here the value of R we have taken to be 0.082 because the pressure is in the units of atmosphere and volume is in the units of the liter. So that's why we have taken the value of R to be 0.082. Temperature is always in the units of Kelvin and it is in the 300 Kelvin. And after calculation we can get. So the value of A will come out to be A comes out to be 21.6 atmosphere liter square per mole square.